Hello everyone and welcome to this session. The session is about electron configuration for atoms, or it's also called Aufbau principle. But before anything, I want to explain some basics that is quantum numbers. As we know, in general, we have four quantum numbers: n, l, m, and this l and ms. S refers to spin, but we want to study two of them. N, as you can see, the principal quantum number, and L, quantum orbital quantum number. As we can see, n is the principal quantum number. Possible values for n is 1, 2, 3 till 7, because we have 7 rows in periodic table, and the maximum number of electrons that are located in each n is given by 2n2. As I said, n is a principal quantum number. But about orbital quantum number, that we show that by L, for the given value of n, the possible values of L can be from 0 till n minus 1. For example, when we have n 3, L can be 0 and 1 and 2 until n minus 1, and it's obvious that L cannot be 3, and the maximum number of electrons for each L is equal 4L plus 2, as I said before. For n, the maximum number of electrons 2n2, and the maximum number of electrons for 1L is 4L plus 2, and I want say something is that the n, the principal quantum number, refers to layer, the energy level of layer, and L refers to sublayer. For example, I want to explain side layer. When n is equal to 3, n is 3, we will have L0, L1, and L2. When L is 0, the sublayer is called S. When L is 1, the sublayer is called P, and when L is 2, the sublayer is called D, and of course, if L is 3, the sublayer is F, and similarly for 4G, and etc. etc. But in sublayer, when n is equal to 3, we can have 3 sublayers. One important thing is that the number of sublayers is equal to the layer. I mean, when in n is 3, we have 3 number for L. When n is equal to 5, we must have 5 sublayer, and similarly, we have such a thing, and the number of sublayers in each layer is equal to principal number, and as I said, the maximum number of electrons in one layer is given by 2n2. N is equal to 3, then 2, 3, 2, and 9 multiplied to 18 electrons we must have in sub layer, and for sub layer in this layer, excuse me, and for sub layers the formula was 4l plus 2. Based on the formula for S, we can have maximum 2 electrons because L is 0, and the answer will be 2. For P will be 6, and for D will be 10, and the total amount of these numbers is equal to layer 10 for D plus 6 for P plus 2 for S is equal to 18, and as you can see, the total number of electrons in sublayers is equal to the number of layer, and in other layers we have such a data, such a situation, and again about Aufbau principle, the definition is the Aufbau principle shows the order in which sublayers are filled, and the order is based on increasing the n plus l principal quantum number and orbital quantum. Accordingly, we must have 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and as you know, 5s and 4d, 5p, again 6s, 4f, 5d, 6p, and etc., etc. But the most important point is that 3D is located after 4s. Why? Because if we calculate n plus l for 4s, 4 plus 0, and the answer will be 4, and for 3D, n plus l, 3 principal quantum number, and L because the sublayer is D, as I said. When L is equal to, the sublayer will be D, and as a result n plus L will be 5, because 5 is bigger than 4. This sublayer 3D must be after 4s in the order of filling based on Aufbau principle. And there are such things in other sublayers. When we write in after cases 6s, 4f, 5d, and 6p, and etc., etc. Such a thing is repeated in this case because 4f is located after than 6s, m plus l, 6 plus 0, and the answer will be 6, and for f, m plus l will be 7, and it's obvious that 7 is bigger than 6. And the one important note is that in Aufbau principle we have two important points. The order of filling sublayers, as I said, it's based on n plus L increasing. The order follows n plus L increasing. We have 1s and 2s 2p, again 3s 3p, 4s 3d, and 4p, and etc. But we have ordered arrangement for the cases that atomic number is bigger than 20. And this point is so important. For example, for nitrogen, we have 1s2 and 2s2 and 2p3. 2 plus 2 plus 3 is equal 7, and it's the electron configuration for nitrogen. But about cobalt, we have the atomic number 27, 1s2, 2s2, 2p6, and 3s2, 3p6, 4s2, and 2 plus 2 plus 6, 10, 12, 18, 20, and again 7, 3, this 7, 27. But most important things, because the atomic number is bigger than 20, we must order the electron configuration. As a result, in this case, we have ordered arrangement like this. We must act 1s2, 2s2, 2p6, 3s2, 3p6, and 3d7 and 4s2. The first one is the order of filling, and the second one is ordered arrangement. And as you can see, it means the total number of principal quantum numbers that are 3 must be in one layer, because they belong to third layer. And finally, I want to explain another things: exceptional electronic configuration. In some cases, electron configuration doesn't follow Aufbau principle based on spectroscopic data, like chrome, atomic number 24, and copper, atomic number 29. For chrome, we must have 1s2, 2s2, 2p6, and 3s2, 3p6, 4s2, and 3d4, and because the maximum number of electrons that can be located in these 10, we must change the number of electrons. This number must be 1, and for 3D must be 5, because D5 is half field and has more stability, and as a result the electron configuration of chrome must be 3s2, 3p6, 3d5 and 4s1, as you can see. In other words, we don't have 4s2, 3d4. We must change 4s1 and 3d5, and for copper 29, 4s2, 39, as I said, because the number of electrons in D when the total number is 10, the sublayer is filled, we must change, and the sublayer will fill and will fill in this state, and as a result the electron configuration for copper is 4s1 and 3d10, and order arrangement 3s2, 3p6, 3d10 and 4s1, and in other words, we don't have 4s2, 3d9, and we must change to 4s1, 3d10. Let me have an overview to this session. There was two important things. One of them quantum number, quantum numbers n and l. N principal quantum number shows the energy level of layers, and orbital quantum number L refers to sublayers, and the other point was electron configuration or Aufbau principle. In the end, I want to appreciate due to your attention.